All right, so I'm going to read it one more time. The length of a rectangle is 7 centimeters less than twice the width. If the ratio of the width to the length is 2 to 3, find the length and the width. So what I recommend is you call one of them x. I would call the width x. And then I would call the length, let's see, 7 centimeters less than twice the width. 7 centimeters less than twice the width. Did y'all do something like that? Call one of them x. You can call the other one 2x minus 7. And then you can set up a proportion. This says the width to length ratio. So 2 is to 3. That's width to length. 2 is to 3 as x is to 2x minus 7. Does that look good? Width is to length as width is to length. You could also do width over width equals length over length. It doesn't matter as long as you're consistent. Karthik, what'd you get? While you're typing, I'll go ahead and show some work. So when we cross multiply, we've got 3x equals 4x minus 14. So Karthik, what'd you get? Very good. Okay, so x is 14. X is 14, so that's the width. We don't have units, centimeters, yes we do. 14 centimeters is the width, and then you do 2 times 14 minus 7 to get the height. So do you want to change your height? Very good. 2 times 14 minus 7, and we get 21. So the length is 21 centimeters, and that width, instead of x, I'll put w. The width is 14 centimeters. Let's check our homework answers. Lots of good word problems on that homework that you might see on your quiz again today. So look at those answers and let me know which ones we need to talk about. Might. On number 2, it's very important that you put that answer as a fraction because it's a repeating decimal. It goes on forever, and we never want our answers to be approximate. We want our answers to be exact. So when you get a decimal that does not terminate, you have to do math enter and put it in as a fraction. It's very important, okay? So number 2, you have to put in fractions. Yes, Kwan? But like number 8, you could put 0.5 if you wanted to. That's fine because that's not a repeating decimal. But number 2, you have to put in fraction form. So x can be negative. Sure. It's always been able to be negative. A side of a polygon can't be negative. But x can be negative. An angle can't be negative, but x can be negative. Sure. That's not new. Okay, 15 and 11. 11, I know that zoomed out so much that you can't see it, but that's okay. A wheelchair ramp has a slope of 1/10. The ramp rises 2 feet. What is the run? We know from prior knowledge that slope is rise over run. And so when it says the slope is 1/10, that's rise over run. So if the ramp rises 2 feet, then what is the run? We just set up a simple proportion. And you just multiply 2 times 10 divided by 1. Boom, got your answer. Make sure on your homeworks that you do put your units though. Okay? You still want me to do 12? The ratio of the sum of the exterior angles to the sum of the interior angles. Okay, let's write that down. The sum of the exterior angles is 360. The sum of the interior angles is n minus 2 times 180. So we got that to that. The ratio is means equals. The ratio is 1 to 3. Now you cross multiply. Ready? So we're going to cross multiply 3 times 360, 1,080 equals n minus 2 times 180. Let's divide both sides by 180. Unless you've already memorized which polygon the sum of the angles is 1,080, that would be cool. 6 equals n minus 2, and then we're going to add 2 to both sides. N equals 8. It said to identify the polygon, and so the polygon is an octagon. Okay, 15. The ratio of the measures of a complement of an angle to its supplement is 3 to 8. What's the complement of an angle? The complement is 90 minus x. What's the supplement of an angle? 180 minus x. The complement to the supplement is 3 to 8. So then you're going to cross multiply that. Okay, so when we do this, we get 3 times 180, we get 540 minus 3x equals 720 minus 8x. And then I'm just going to let you solve from there because we need to do our lesson, okay? Title your notes, dilations. A dilation is a transformation that enlarges or reduces the size of a figure proportionally. Proportionally is very important. When you dilate a figure, you get a similar figure. And the symbol for similar is a squiggly. So this symbol is congruent, this symbol is equal, and this symbol is similar. So you got congruent, equal, similar. I did teach transformations, but I didn't teach dilations yet. We did rotations and reflections and translations, but didn't go over dilations. All right, have you ever had your eyes dilated? Like officially dilated at the eye doctor? Yeah, it's not fun. It's kind of weird. But so anyways, how your eye works is that when the lights are off in dim light, the pupil gets larger, the iris gets smaller. I think I'm using the right terminology. And then when you turn the lights on, boom, it shrinks. And that's how you can make the connection to dilation, enlarging and reducing. So real quick, here's an image off of YouTube of a pupil being dilated. So they turn the lights off. And then look, did you see how it shrunk up when the lights came back on? So the pupil got larger, and then as soon as the lights got back on, see, it's getting bigger, see? And then ready, set, go. Maybe, come on, go. There it goes, shrinks a little bit. So anyways, that's all I wanted to do with that. Dilation, it's an enlargement or a reduction. That's what I want you to get out of that. So we already did that. Just a second. Okay. All right, so we're going to dilate some things. Here's an example of a dilation, A, B, C, D, E. I guess the E is gone. A, B, C, D, E is dilated and becomes A prime, B prime, C prime, D prime, E prime. What occurs from the pre-image to the image? So it's pretty much just asking what happened to the figure. It was a reduction, very good. And how much was it reduced by? It got twice the size? No, it got half the size. Very good. 5 is half of 10. So the scale factor to get from here to here is 1/2. A prime, B prime, C prime, D prime, E prime is half as large as A, B, C, D, E. All right, what's the diameter of the image if the scale factor is 3/2? So we're actually going to talk more about scale factor tomorrow, but you know that when you have a scale factor and you want to get from one figure to the next, you just multiply that figure by the scale factor. So we're going to take 8 and we're going to multiply it by 3/2, which is also 1.5. 8 times 3/2 will get us our new diameter. 8 times 3/2, 8 times 1.5. Very good. You're all getting 12. You're correct. 12. So when you see scale factor, you should think multiply. When you see scale factor, you should think multiply. What is the scale factor? $13. Try to think what number could you multiply 8 by to get 104? And you're all saying 13. 8 times 13 is 104. Very good. So the scale factor is 13. How'd you come up with that? Good. You did 104 divided by 8. So you took the second figure and you divided it by the first figure. Very good. So the scale factor is a number that describes the size change. It's a number that describes the size change. If your scale factor is greater than 1, it's an enlargement. If your scale factor is less than 1, it's a reduction. And if your scale factor is equal to 1, it's called a congruence transformation, because nothing's going to happen to your figure if your scale factor is 1. So it's a congruence transformation. Okay? Greater than 1 makes it larger. Less than 1 but greater than 0 makes it a reduction. And then equal to 1 is congruence. All right, determine if the dilation is an enlargement, a reduction, or a congruence transformation. I'm insulting your intelligence, so I'm going to just start calling on you. Number 1, Eric. Enlargement, reduction, or congruence? Enlargement, very good. Adriel, number 2. Let's just abbreviate. Adriel, number 2. Reduction, thank you. Johan, number 3. Yeah. Don't get fooled by the 2/3. It's 6 and 2/3. Araceli, number 4. And then Quan, number 5. Congruence, very good. And Quan, enlargement, very good. Because 5/3, even though it's a fraction, that one's greater than 1 because it's an improper fraction. Okay. Use the figure below to answer the following questions. What is the scale factor? I'm going very quickly because y'all need time. Okay, so I'm just going to power through this. So, how would we find the scale factor? We would need to find some side lengths, and then we could put the second one over the first. Write that in your notes. Second over first, because that's how you find scale factor. 1, 2, 3, 4, 5, 6, 7, 8, 9. That side is 9. 1, 2, 3. That side is 3. So what's the scale factor? It's 9 divided by 3. So the scale factor is 3. This shape is 3 times larger than ABC. So if BC is 3, which we know it is, then B prime C prime is 9. If A prime C prime is 10.8, then what is AC? Now, I told you when you hear scale factor to think multiply. But what if you're going backwards? You're not going from the first figure to the second figure. You're going backwards. You would just do the opposite of multiply. Very good. So 10.8 divided by 3. And that gives us 3.6. We're getting smaller. If the measure of angle BAC is 50 degrees, then what's the measure of angle B prime A prime C prime? How'd y'all know it was 50? You didn't divide it by 3. Very good. So when figures dilate, when we have two similar figures, their angles are going to stay the same. Their angles are going to stay the same. So we're going to talk more about that tomorrow. But the angles, even though the sides change, the angles are going to stay intact, completely intact. Not percent. Okay, triangle ABC is similar to triangle A prime, B prime, C prime. That squiggly means similar. All right, what's the scale factor? Just be careful. We're getting smaller, So it better be less than 1. So this is 2 and this is 3. You put the second over the first. Your answer better be less than 1. If you answer 3/2, you'll get it wrong. What's the scale factor? I'm trying to go quickly. 1, 2, 3, 4, 5, 6. That's 6, and that's 2. Be careful where the primes are. B prime, A prime is 6. That's the second, and the first is AB. 6 over 2. So our scale factor on that one's 3 because it's getting larger. I'm going to skip some because I think we get it. Okay, now this one you would want to count the side that you're allowed to count. You would count that side and you would count that side. Don't try to count diagonally. Don't ever count diagonally. Count the sides that you're allowed to count, vertical or horizontal. All right, we did make it through the lesson, so start your quiz immediately.